Welcome to ArmanisMath. Today we're going to focus on math operations with complex numbers. Adding, subtracting, multiplying, dividing complex numbers. Here's a warm-up. I'll give myself about 3 minutes for this. I'm going to pause in a few seconds. It's just for you when you watch afterwards. Right. So let's start with the first one. Add and subtract and then simplify. And this one is straightforward since I have a positive. If this is negative, then I would just be a little bit more careful. Positive doesn't really change the sign. So I'm going to say this is 2x plus the 3. Distribute that. That's going to be minus x plus 3. These two I could combine. Numbers I could combine as well. We've got 1x plus 6. Second one here says multiply. I'm a big fan of using something called the box, and the box is pretty powerful because it is flexible and it expands. Foil obviously is another one. Distribution is another one. So I'm just gonna elect to use the box since I could see things visually in front of my eyes. And also foil is limited. Foil only gives you a binomial, like a bicycle, 2 items times 2 items. Once you get better, get more than 2 by 2, then foil fails you, and it just looks at you funny. What are you trying to do? I only can do 2 by 2 here, foil. But the box, you could have 5 times 6, 2 times 9, whatever numbers you have of terms. 2 times 3 is 6x squared. This is 3x. I've got 10x and I've got a 5. So this will be 6x squared. I'm going to collect these in the box here since I've done some of them in the past, so I could just collect this with that. Got 3x's and 10x's. That's going to give me 13x's and plus 5. I'm going to box in my answer. Last but not least is the guy down here, and again I'm going to use the box for this. You could distribute foil, but I'm going to use the box. Okay, here we go. Alright, here we go. Got this good looking box here. Attractive looking box. Doesn't matter which one you put, by the way, on the side or the top. You just make sure that you put both. It's a plus sign here. And I've got x minus square root of 3. I've got x squared, x squared 3 minus x squared 3. And then square root of 3 times, a positive times negative is negative. Square root of 3 times square root of 3 is just 3. And again here I'm going to use my fruit ninja, and chop chop. I'm going to chop this with this because these are opposites. And then I'm going to say, well, here is x squared minus 3. And that should be my solution here. If you are in doubt on how to multiply radicals, watch one of my videos that talks about multiplying radicals. Square root of 3 times square root of 3 is going to be square root of 9. Take the square root of that, which is 3. Okay. Here are some answers nicely printed. Are you looking up or down? Am I looking up or down here? Is it complicated? Yeah. It's because of complex numbers. Objective, I will be able to add, subtract, multiply, and divide complex numbers and find complex solutions of a quadratic equations, of quadratic equations. Do we ever use this in real life? The answer is yes. Electrical engineers, electronic engineers as well, use complex numbers, real and imaginary, to help in AC circuit calculation, AC alternate current circuit calculations. Okay, so if you found another example or real life example, let us know in the chat or also in the comment. Subscribe, like, and share. Here we go. What is a complex number? Well, a complex number is any number that can be written in this standard form, a plus bi. A being the real part, bi is the imaginary part. As it says here, a and b are real numbers. So for example, I could say 2 plus 3i's. The 2 is the real part of it. The 3i is the imaginary part of the number, of a complex number. When does this idea even became vivid to mathematicians? Well, this was back in the 17th century when they tried to solve quadratic equations. We all could solve them, but what would happen if you have a quadratic equation that looks like this? X squared plus 1 equals 0. Well, Armani, that's easy. I'm going to subtract 1 from both sides. Sure, do it. So you subtract 1 from both sides, you're going to end up with x squared equals -1. Then you have to take the square root of -1. Well, that is exactly the need that arises back then. What's the square root of -1? So they named that, they called that an I, imaginary part. And these are the solutions that do not touch the x-axis, if you recall. Okay? There are solutions, but they're imaginary solutions. The imaginary part of the complex number. So we're going to focus on the I now, okay? So a plus bi, we're going to focus on this I here. So we said I is the square root of -1. I squared is I times I. So if you multiplied, I'm going to make myself a room here. If you multiplied square root of -1 squared, remember you're squaring the square root, you're going to end up with the square root, which is going to be -1. Okay? If you want to really know what's going on here, well, this was an index of 2, if you recall. This is an x of 2. When the indices, the index here for the root is actually an exponent, but a fraction. So basically what you're saying here, I have a -1 raised to the half power. That's the square root. But the entire thing is raised to the second power, which is this dude here. See that? So what's 2 times 1/2? That's just a 1. And that's why you end up with -1. Okay, so I squared is -1, and I'm going to put that in multiple slides because I want this to be engraved in your brain. This lecture requires really a lot of attention, so if you're distracted somewhere, please sit down somewhere where you can't be distracted. Make sure you have your writing utensil or utensils, and then you focus because it does require focus. So what if I want to play with some eyes now? An eye for an eye. Okay, let's see what's going on here. I'm going to say, what is I to the first power? Well, that's just I. There's nothing magical about that. I to the first power is just an I. Okay. So I to the first is an I because it's just anything which is the first power is itself, right? How about I to the second power? Well, this is I times I, and we just found out the value of it is going to be -1. How about I to the third? Well, I to the third is interesting because it's I to the second times the I, right? I to the second I have a value here for, which is -1. So it's -1 times the I, or basically you're saying it's a negative an I. So I to the third is a negative I. talk about some more here. I've got I to the 4th. Oh, yeah, yeah. And then I to the 5th. And then I to the 36th. And then 53rd. Don't get panicked. Do not panic. I to the 4th power is I to the 2nd. To the 2nd power. I to the 2nd power raised to the 2nd power. Well, I know what's I to the 2nd, Armanis, right here. Thank you for having this for us here. Yes, I know. You're welcome. So basically you're saying it's -1 squared. What is -1 squared? That's 1. Good looking 1. How about I to the 5th? Well, it's I to the 2nd power raised to the 2nd power times another I, or I to the 1st. Well, we just did that. If you looked up here, I to the 2nd raised to the 2nd power, well, that's going to be just 1. So it's 1 times I, or just an I. I could write it here. 1 times I equals an I. All right. How about the 36? Well, that becomes interesting. So I wanted you to think about this kind of numbers, or these numbers, in terms of odds and evens, okay? So for even numbers, you know that they're divisible by 2. So 36 is divisible by 2, which is going to give you how much? How much is 36 divided by 2? I know 30 is 1 and 16, 18. So I'm going to say this is actually an I to the 2nd power raised to the 18th power. You also could reverse them, by the way. You could say I to the 18th raised to the 2nd power. Both would work. But because I know I to the 2nd power, that's this dude here. See that? See that? These are awesome guys here. So I to the 2nd power is -1. So I'm going to say it's -1 to the 18th power. Okay, well, -1 raised to any positive power is going to be 1. And here's the hint up here. I squared is going to be -1, but when you raise it to a negative power, it's going to give you a 1. So -1 to the 18th power, it will give me a positive 1. How about this guy here? Well, 53, think of it this way. 53, you could think of it 52 plus 1. Okay? And how do you divide 52 into 2s? What's 52 into 2s? 50 divided by 2 is 25, so that's going to be 26. So, and this guy is going to be 26 times 2. So I'm going to come here and use the same trick. You usually want to focus on I squared, okay? If you go down to I squared, you're golden, because you know I squared is going to be equal to what? Hello? -1. So I got I squared raised to what power? To the 26th power. Well, that's not scary, because I squared is -1 raised to the even power is going to be 1 times whatever left, which is I to the 1st. That's going to make the 52 here. So this is going to be an I to the 2nd power, which is -1 raised to a even power. It's going to give you 1 times the I to the 1st power, or just I. So 1 I, or just an I. And I boxed in the answers after an I and a 1. All right. That's how we deal with the eyes. An eye for an eye. No. We need to love our neighbors. Okay. All right. Square roots of negative numbers. So I have a square root of -a. Well, if you look closely here, you're talking about two things here. If you look closely here, you are looking at square root of -1, right? Do you see that? Times the a. The square root of a. You could separate them like that. And square root of negative 1 we just talked about being an I. So it's I square root of A. So square root of negative A is actually I square root of A. Right? How about here? Well, this same concept here. Square root of negative 3 is square root of negative 3 is 3. I should say square root of 3 times 1I. Would you come up with this 1I? Armani. Well, this is a negative 1 here. Remember, this under this guy there's a negative 1 and there's 3 multiplied. So the negative 1 is an I, and the negative square root of negative 3, sorry, square root of 3 is just square root of 3. Okay, times. I've got this dude here. Same thing. Square root of 12. Right? And then I have an I as well. So let's slow down a little bit here. I've got a square root of 3 i's. Remember, the I is not under the square root anymore. Times, I've got, in this case, a square root of 3 times, actually, hold on a second. I could just multiply the like terms. So square root of 3 times square root of 12. I could multiply these guys, right? So square root of 3 times 12. How about the other ones? Of course I could do that. I times the I. Yeah? So I'm going to say times I squared. So what's the square root of 3? Let's be patient here. 3 times 12 is 36. And I squared is basically a negative 1. Yes, don't forget that. So I've got I squared here. So if you are looking at the final answer is going to be a negative 6. Why is it negative 6? Because the square root of 36 is 6, and I is just a negative 1. I squared, I should say. I squared is negative 1. Okay. How about this dude here? Well, this is also equally amusing, dude. If you could break the 48, you're going to find yourself looking at a 16 times 3. 16 times 3. Yeah, because 15 times 3 is 45. So 16 times 3. So this 48, if you want to break it down, negative 48. It's going to be again a negative 1 times 16 times 3. Okay. So don't forget that the negative square root of negative 1, that's just an I, times square root of 16 times square root of 3. Okay, well, this guy here is an I. I know this is an I here. Square root of 3, 16 is 4, square root of 3, and there's an I. Okay, which is this I here. So usually you put the number and then put the I. So now I have, for this guy, I have actually 4, square root of 3 i's. Don't put the I under the square root. Okay, that's a square root. And minus. What is this guy here? Well, if you know 27, it's 3 times 9. So I know the 9 is going to be, this one here has a 9 and has a 3. I know the square root of 9. Square root of 3. Don't forget there's a negative 1, right? So negative 1 times that. Negative 1 under the square root. So you have an I, and then you have square root, that's a 3, square root of 3. You have a negative 1, which is just the I. So I've got 3 square root of 3 i's. Well, look at this for 1 second here. I'm talking about four items of one thing. That's four of this thing here, and 3 of that same thing. So, for example, if you have 4x minus 3x, that's just 1x, right? So think of it that way. So 4 of that minus 3 of that is just exactly 1 of that, which is the square root of 3 times the I. You might need to watch this again, okay, when you review the video. All right. Moving on. Equality of complex numbers. So you say a complex number is equal to another one if their parts are equal as well. Two complex numbers are equal if and only if, there's an I here, if and only if the real and imaginary parts are equal. So what do you mean by that? Remember, this is the real, this is the A part, right? Which equals to this A part. And this part here, the BI part, is equal to this BI part. So if that is true, then x has to be equal to 3. And the y has to be equal to 5. For this to happen, this condition has to be fulfilled. If you're saying that the real parts have to be equal to one another, and the imaginary parts have to be equal to each other. Okay, that's the real imaginary part. Adding and subtracting complex numbers. So it says if a plus bi and c plus di are two complex numbers, then the sum of them is going to be like this. You're adding the corresponding parts. You're adding real to real, right? I'm adding real to real. I'm adding a to the c, a plus c. And I'm going to adding bi to di. So you're going to say b plus d, and then you have the I in common. Same thing with the difference or subtraction. You also subtract the real from real, and then the imaginary from imaginary. So a minus c, and then b minus d, the I. Let's take an example. Two examples, actually. So the first example says I have 3 minus I plus 2 plus 3 i's. Well, again, if we want to add, you add real to real. So I'm going to 3 plus 2. And I have a plus sign here. That's what I'm going to use. And then you got a negative I plus 3 i's. Well, you have 3 i's minus 1 I. That's 2 i's. So what is 3 plus 2? That's 5. Plus the 2 i's. Okay. Next one. I've got 2i plus negative 4 minus 2 i's. Oh, whoa. Hold on a second, Armani. I thought we have real and imaginary part to these complex numbers. The answer is yes. If you looked at this guy here, this is the imaginary part of something that is missing. So if you have something that is missing, you actually supply it yourself. You just have to put 0 for real plus the 2 i's. That way now we have two parts, the real and the imaginary. Same thing with the imaginary, by the way. Any number could be written as that, any real number. For example, if I say 2, that's same as 2 plus 0 i's, right? You could write it that way as well. All right, so now I have two parts, so 0 minus the 4 and 2 minus the 2. So 0 minus 4, that's the first parentheses, plus got 2 i's minus 2 i's. All right, well, that's just going to go bye-bye. That's 0 here. 0 minus 4 is negative 4. All right. All right. Okay, multiplying complex numbers. That's my favorite, by the way. Multiplying complex numbers. I really have to get you to remember that I is the square root of -1. I squared is -1. Don't forget that. I squared is -1. And we really like I squared because you want to see a number, -1. You don't want to really, you want to avoid square root of -1. So basically what we're after is always, as much as possible, to end up with an I squared. So here it is. I've got I times -3i's. Well, there was something here next to the I, right? There was 1, right? There was supposed to be a 1 here. 1i. So it's 1 times -3. Well, that's -3. And then I times I, that's I squared. Armani, I know it's I squared. Yes, it's here. You're welcome. So that's actually going to be a -3 times -1. Oh, that's just a 3. I love this. I love this. Okay, more on this to come. What if I have something like that? What if I have something like this? A binomial and another binomial. 2 items times 2 items. Well, again, I'm a big fan of what? Of the box. Somebody use the box. I want to use the box. Maybe I could put the box here. I could put the box here. I'm gonna box this here. It's right there. Okay, I'm gonna put the box here. And then try to put my spiel. So it's 3, 2 i's plus 2 i's. I got 4 minus the I. Alright, let's do this. 3 times 4, that's 12. And that's an 8 i's. And I've got 3, that's a -3 i's. And 2 times plus 2, positive 2 times -1, that's an, this is, by the way, this is an I. Be careful here, it's an I. This is a respectful I. We're going to respect the I. So you've got positive times negative, that's negative. 2 times 1, that's a 2. I times I is I squared. Oh, okay. And I would not advise you to do simplification here. Write it down the way it is. It's just easier that way. Here's 12 plus 8 i's minus 3 i's minus 2 I squared. Well, these two I could combine. That's 12 plus 5 i's. And I got minus 2. And what is I squared again? Oh, I can't hear you. Oh, -1. Thank you. -1. So basically, I've got 2 plus 5 i's plus 2. Interesting. So the 2 and the 12 is going to combine. So it'll be basically 14 plus, give myself more room here, 14 plus 5 i's. That's the standard form, by the way. 14 plus 5 i's is standard form, since you have the A plus the BI part. Let me fix one little thing here. That's not okay. So this one is a 1. 14 plus 5 i's. Obviously you could distribute, right? You could distribute here, this times that, and then this times this, and this times this, and this times that. And you also could end up with the same. You will end up with the same. Okay, here we go. Okay, here's another one. This one says multiply. This one says multiply 2 minus I plus times 4 plus 3 i's. Okay. So again, I'm back to my action. This time I'm just going to distribute, okay? Just for a different flavor here. I like the box, but come on. So 2 times 4, and then minus I, 2 times 4, and now it's up to you. Probably distribution is much faster. So 2 times 4, and then 2 times positive 3. So plus 2 times 3 i's. And then I'm gonna do the negative, which is different color for this guy. It's easier. Negative and then negative. So negative I times 4 is 4 i's. Also negative, that's a negative I times 3. It's 3i squared, because I times I is 3i squared. That is I squared. Okay, enough of different colors here. This is 8. I've got plus 6 i's and minus 4 i's, minus 3, negative 1, because I squared is negative 1. Thank you. You're welcome. And that's going to be 8 plus 2 i's, and I've got plus 3. 8 plus 3, and that's 11 plus 2 i's. 11 plus 2 i's. All right. That's an I here. Don't forget this is an I. An I for an I. No. Love your neighbor as yourself. Okay. Let's move on. Multiplying. Multiplying complex numbers. Let's do this. Watch this for a second. I see something plus something, and I see this the same thing minus the same thing. Interesting. Just keep that in mind, because that's there's a shortcut for this dude here, but just for now, keep that in mind. So once again, I could use the box, I could use distribution. So maybe distribution for this case here. That's funny. Like this. Whew. And let's change color for the other ones. So let's do that. I've got 3 times 3. 3 times 3. I need to give myself more room here. And I've got 3 times negative. That's a negative. 3 times 2 i's. And I got the negative counted for. And then I've got plus 2 times 3, or 2 i's times 3. And I've got positive times negative, that's a negative. And then 2 i's times 2 i's. Well, that's a 4 i's squared. All right. Let's focus on here. I've got 9 minus 6 i's. 2 times 2, that's plus 6 i's. Minus 4 times negative 1. Okay, Fruit Ninja, these are gone, and I leave myself with minus 4 times negative 1. Well, what is negative 4 times 1? That's positive 4. 9 plus 4. So basically the answer is 13. Yeah, it looks interesting. So there is a shortcut, obviously, here. There's a shortcut here. I might want to just, since you guys are awesome, I'm going to just add it here, okay? There's a shortcut. The shortcut is called difference of squares. Difference of squares. So if you have a squared minus b squared, that will give you a minus b, a plus b. Okay, that's called difference of squares. What is the difference for squares? Because there's something b squared minus something else being squared. So basically, the word in difference in math means subtraction. So I have a squared minus another squared. The a is being squared. So think of it this way: if you apply this to this here, you actually have yourself, different color for this guy. I have 3 minus 2 i's. Doesn't matter which one you start with. and 3 plus 2i's. Well, what do you think is going to be here on this side? Well, whatever you're squaring. I'm squaring the what? Squaring the 3, right? That's the first term, which is 3 squared. Minus, I'm squaring the second term, which is the 2i's squared. That's a 9 minus, look at this guy, what's happening here? Well, this is 2 times 2, that's 4, I squared. And this is going to take you back to 9 minus negative 4, which is the 13. So obviously you don't see the benefit of this shortcut here, but when you have large numbers, it makes perfect sense. Difference of squares will help you a lot in the future. That was a bonus, by the way. Okay, just for those who want to excel and go above and beyond. All right. This is what we got for this guy here, 13. Nice and neat. I would put these somewhere, by the way, these little hints here. I would put them somewhere in your homework, quiz, test, index card, download an app, whatever you have to do. Make sure that you know I squared is -1 and I is square root of -1. Okay, what is this idea of the conjugate? Conjugate. Well, the complex conjugate of a complex number. What? A complex conjugate of a complex number. Z is that number, complex number, a plus bi. Then z conjugate, this is the prime or conjugate. Z conjugate is actually you just replace a plus bi becomes a minus bi. So watch this for a second. This is plus here. That becomes a negative here. That's the conjugate of it. Do you use this one? We use this concept for dividing complex numbers. We've talked about adding, subtracting, multiplying, and now we're going to talk about dividing complex numbers. To divide complex numbers, you will need to use the idea of the conjugate because you have to do that for the denominator. All right, let's take a look. Divide complex numbers. I've got 3 divided by 5 minus i's. Here's something that I really need to be honest about now, and that is complex numbers, the one with the i's, do not really like to reside in the denominator. They do not like it. Just like the square root, they don't like it, and you rationalize. Same thing for the complex numbers. They do not like it downstairs. So if there's any i's in the denominator, it doesn't really like it. So you have to move it. So how do you move it? You use the idea of the complex conjugate. So in this term here, what we need to do is actually have, this would be a 3 over 5 i's, 5 minus i, 5 minus i. And because, again, you want to get rid of that conjugate at the, you want to get rid of that I at the bottom, you have to multiply it by its conjugate, and the conjugate of 5 minus I is 5 plus I. Well, that's gonna get rid of it down here, but this is a fraction. Whatever you do to the bottom, you do to the top. So also the top has to be 5 plus I. Basically, you're trying to fool the problem because you basically multiply by 1 here. Okay, it just looks different 1. But it's a 1 because it's the number divided by itself. So you're not affecting the value of the problem. You're just manipulating the fact. Anyways, so now you're going to multiply the top by itself. So we're going to have 3 times this spiel here. So 3 times a 5 plus 3 times the I. All what I'm doing is just distributing here. And the bottom is the same. We just talked about that moments ago. Okay, divided by 5 times 5. So you could distribute to the box or whatever you guys have to do. Maybe for me, I'm just going to do a quick box here. Not bad. I've got 5 minus I. Make sure that you have the sign with it, not just by itself. That's 25. That's minus 5 i's. That's 5 i's. And that's a negative I squared. So these two are gonna go bye-bye. And I'm gonna end up with 25 minus I squared. Well, I squared is negative 1, right? So I'm gonna go back here and say this is 25 minus I squared. 25 minus negative 1, or actually 26, right? So believe it or not, this whole shebang turned out to be just a 26 at the bottom. Now there's a nice way to put things. There's a polite way to say hi. There is a polite way to talk and to respect people. So right now it's fine, but it's not that respectful. So 3 times 5 is 15. Just cleaning up things just a little bit. 3 i's, and then you have divided by 26. So the polite way to do it, which is again the standard form, is to have the a part by itself and then the b part, the bi part, remember the imaginary part, which is 3 over 26, and then we have an I here. I, it belongs to both of them. Okay, that's this problem. Look how happy this denominator now is. It has no i's in it, and it's very happy, very jolly. All right, champions. We are gonna take one more, okay? Since this is an area that we need to focus on. This one has 2 plus I, and then divided by 3 minus 2 i's. And we're asked to divide, obviously. So how do you divide? Well, once again, Armani, we do not like having i's in the denominator. That's, I shouldn't have even green for that one. I should have red. Don't have that here. Don't have this. So you could do that again. You could get rid of that by multiplying top and bottom by the conjugate. The conjugate of 3 minus 2i is 3 plus 2i. We said you do it to the numerator and the denominator because you're not affecting the value of the problem. All right, let's keep going here. So I've got 2 items times 2 items, and I'm definitely going to use a box for this. Yeah, I really have to choose a box for this. I'm sorry. You could choose whatever you like, but I am going to choose the box. And I'm going to do actually 2 boxes because it was one at the top and one at the bottom. So here's the first box, and here's the second box. Box the top, box the bottom, and here's the top. I've got 2, so basically I've got these here multiplied and these here multiplied. Be patient, okay? Be patient. 2 plus the I times 3 plus the 2 i's. That's a 6. That's a 3i. That's 4 i's. That's a 2i squared. Okay, and I probably could do the collection here. So at the top I have actually I could simplify just a little bit here because I know that these here, for example, see this and this, this is 7 i's. So basically what I have here at the top is 6 plus 7 i's plus 2i squares, and I know I could do something about that. I'm just waiting I'm waiting for a second, okay? Just wait. And I'm gonna do now the bottom one. So I've got 3 minus 2 i's. Minus 2 i's, and I'll also have 3 plus 2 i's. Now you could use this box, which I have here, or you could, if you looked closely at the last trick that I shared with you, a trick, a shortcut, if you have difference of squares, right? So I'm gonna leave this for you to fill in. But I'm going to use the difference of squares. To me, this is 3 squared. And I have minus, it's a difference of squares. Basically, I've got 2i squared. Okay. I have to be very careful here because 2i squared, the whole thing is being squared. Okay. So this one here is 9 minus, I've got 4, 2 is 4, and then times -1. Well, that's a -4, that's a 13. So I'm going to go back here and put 13, okay? So at the top I've got 6, and then by the way, what is 2i squared? Well, that's 2i times -1, that's a -2. So basically at the top I've got 6 plus 7i minus 2, right? Divided by, I've got this guy at 13. We already have, that's, you know this from here. And let's just clean things up a little bit. I've got myself a 4, good looking 4, plus 7 i's at the top, divided by 13. And we said this is kind of polite, but not that polite. So 4 over 13, that's the a part of the complex, divided by 7 over 13 of the i's. And that looks like the standard form of the complex number, which is a plus bi. B the change you want to B just change you want to C. This is the A, and this plus the bi, remember? Complex number, standard form. Okay, so I left this for you to fill it in. You should end up with 13. I used the shortcut that I used in the last problem, which is the A squared minus B squared. I did that. All right. It should look like your problem, nicely printed. All right. Here's the last concept we're going to focus on here is the discriminant of a quadratic equation. The what? The discriminant. There's no discrimination here, it's just the word. Discriminant is referring to a particular part of the quadratic equation, and that part, believe it or not, is under the square root. This is what they're talking about. This is the discriminant. That's the discriminant. Why did they call it that way? I have no idea. They could have called it something like what's under the square root, or the cute thing under the square root, or something. But they decided to call it the discriminant. So what does that mean? When you do the quadratic equation, you'd be able to tell if you have real solutions, 2 of them, or 1 real solution that is repeated, or actually if you have no real solution but you have complex numbers. Okay? And it's all under here. So I might want to highlight that for you, just in case, if you did not see my previous. See, this value is what we're looking for. If this value is positive number, then you have 2 real solutions. 2 real solutions. If this value here is a 0, then you have only 1 repeated solution. Remember that parent that I drew at the beginning? And if you have value here that is less than 0, like negative value, then you have 2 complex, complex solutions. So maybe if I were to graph it again, just for your leisure, I have this here. This is 2 real solutions if it's greater than, so I'm expecting something like this. Right? 1 here, 1 there. Is a real solution because you're touching. How about the second one? Well, the second one looks like, if you guys remember the parent, right? Like this. It's got 1 solution that is repeated. Remember that repeated, the multiplicity repeated here. How about the third one? Well, the third one, Armani, will look like this. Try the blue one. Okay, the third one, which is this guy here, is something like like outer space or something. It's not touching the y-axis. Still parabola. Excuse my parabola. Excuse my parabola. It's still a parabola, but you're not touching the x-axis. That's not real. That's complex. It's imaginaries. Okay, so how do you determine these? Well, you just have to look under the square root of the quadratic formula. Discriminant. Alrighty. So, use the quadratic formula to solve this problem. And by the way, this is going to be the last example we have today. Thanks for hanging around until now. I know there was a lot today. You guys are champions. So obviously, before you use any quadratic, I would love for you to really label things. So this is A equals 3. Write it down. It's okay. Write it down. This is B equals -2. This is C equals 5. Okay? So to use the quadratic formula is you have to remember the formula. And how does the formula go, Armani? I forgot. Was the last slide. Okay. I'm going to put it here for you, okay? I'll put it here. So x, the formula goes like this. X equals minus b plus or minus square root of discriminant, the b squared minus 4ac divided by 2a. Okay, are you now satisfied? All right. So let's do it. I will be patient and I will be careful because I've got to substitute all these values and be careful. All right, x equals negative. What's my b? Well, got a -2 Armani here. Plus or minus square root of b. Okay, again, what's b? -2 squared. Okay, I got minus the 4, the a, that's a 3, the b, the c, that's a 5. And I'm not sure if you could see what I'm seeing here. I just noticed something here. That this is a negative and I'm multiplying a big number here and this is just a little number. So most likely I'm going to end up with negative. Do you agree? I think you see it as well. You guys are awesome. Okay, so x equals. Here's a 2. Negative times negative is positive, right? And then plus or minus square root of, I got a 4 minus, and I'm going to just do the 4 times 5, that's 20. Times 3, that's 60. 4 times 5 is 20, times 3 is 60. Divided by 6. Okay, I'm going to have to keep going here. I'm going to be patient again. Got 2 plus or minus square root of 56. 56. Oh, it's not 56 for Armani. It's actually negative. Oh, big deal. Yes, of course it's a big deal. 56. Because once you had negative under the square root, now you're talking about the imaginary ones. Come on. Okay, now what's the square root of 56? Well, 56. I could slice this boy in half into... I could slice this number in half into... looks like I've got a 14 times a 4 or something. That's the biggest that I could get. 4 times 14. Okay, so I'm going to take the square root of 4, square root of 14. Square root of 4, square root of 14. Okay, so this means square root of 4 is 2. Square root of 14 just itself. So I'm going to come here and say I have myself x equals 2 plus or minus another 2 square root of 14. And then because this is a negative here, we have to be careful. See that negative? That's not going to go away, Armani. That's going to stay with you. So like -1 here. Square root of -1. And we already have developed the concept of -1 being an I. So there's an I here. Divided by 6. Can we clean up things up a little bit? The answer is yes, we can. The answer is yes, we can. You could clean this up a little bit by looking at the 2 and the 6 this way diagonally, and also the 2 and the 6. So you're going to say 2 divided by 6. That's a 6 here, plus or minus 2 square root of 14 divided by 6 the i's. Okay, let's be patient. And that's going to give me the final answer, which is 1/3 plus or minus square root of 14 divided by 3, because this 2 is going to go with this. Let me use my fruit ninja. The 2 and the 6. The 2 and the 6. Okay. Going back here. Of the i's. And that should be my final good looking answer. Very attractive answer. Look at that. All right, so what have we done in this problem? Well, what you've done, Armani, in this problem is you've taken a quadratic equation and you have used the quadratic formula, which is here. And right off the bat, you looked here and you noticed something. Remember, you guys, when I said I noticed something? That's a big number, a big negative number. Subtract from it a little positive number, so I'm going to end up with negative under the square root. And if you remember from last slide, we have a negative as a discriminant. That's the b squared minus 4ac. Then you should expect to see imaginary answers, complex numbers like this. That's exactly what happened to us. Okay. This should conclude our presentation today. I know it's a lot, but you guys are champions. And you did it. If you got to this point, you are doing an awesome job. Keep it up, keep the hope up, and keep our eyes up on the one who gives hope. Take care, guys. God bless you all. Bye-bye.